morning and welcome to the Aura Innovation Center. So I'm Chun from the Flood Innovation Center, which is a sister brand to the Aura Innovation Center here at the University of Hull. So today I'm going to show you the PCB suite in the workshop as part of the InventX series online. So let's come along for the ride. Hello, good morning, everyone. I hope you like that little bit of intro. And before we get started properly, I'd like to say some housekeeping as well. So if you have any questions or any questions during the webinar, just leave them down in the Q&A section. You should see them in a bar on top or below your screen. And you can also use the chat box as well. If you have any questions that you want to ask or anything, any comments that you see, and we can then actually answer these questions as we go along. So before I get into the proper demonstration bits, I want to just give a quick recap to the Flood Innovation Center and the Aura Innovation Center. They are part of the University of Hull's industry-facing innovation support centers. Both innovation centers are actually located based in Hull. The Aura Innovation Center is based in Hessel at Bridgehead, and so very locally accessible. So the Aura Innovation Center focuses on low carbon technologies, whereas the Flood Innovation Center focuses on SMEs which are looking to develop innovations and products and services which are catered to the flood sector. So so a lot of the SMEs that we work with don't traditionally only operate within the sector. So if you have any ideas or any questions that you may have, the best thing to do is to actually approach us, both the Aura Innovation Center and the Flood Innovation Center, and talk to us about your innovation, and so we can help them. So let's go on to the next slide. So besides the Aura Innovation Center and the Flood Innovation Center, we have 3 other programs and projects which are also industry facing, and they're all part of the innovation support package from the University of Hull. So we now have 5 projects which are actually looking at helping the industry, local SMEs and businesses to develop their ideas and products to be able to offer them to their clients and consumers. Okay, so let's go on to why we're here today. So printed circuit boards. So as part of this InventX demonstration series, printed circuit boards. So when you think about printed circuit boards, where and what devices do you think about? So, you know, they're commonly seen in our mobile phones, in our laptops, in our tablets, you know, even our headphones, and they're so pervasive within our own lives, within our own daily lives. I think it's almost impossible to actually go into a place or into a home or an office and not see a single piece of electronics. So even your microwaves, even your washing machine, dishwashers, they all have electronics on there. And nowadays, there's so many wearables that you have that needs electronics, and they all need printed circuit boards. So this is something that you would see inside a tablet or a laptop behind it. And then this is a close-up picture of a printed circuit board with some resistors on it. So the key question is, why do you need printed circuit boards, and why is it important for a business or for your company to want circuit boards designed or prototyped and made? So the key questions are, what are the advantages that printed circuit boards or electronics can bring to your businesses? So essentially it has the ability, so with electronics, it has the ability to measure, record, or log and control anything that they can think of. So for example, if some of you guys who've watched the Formula 1 British Grand Prix over the weekend, obviously you can see that there's a huge accident on lap 1, and immediately they were able to understand, they were able to see that the Max Verstappen, one of the drivers who's had the accident, has had a 51G impact. And so the medical crew immediately was able to then process that information and be able to get Max onto the correct care as soon as he's out of the car. And so having that piece of electronics in there embedded in the car enabled them to measure, record, and control the situation from there on. So making innovative, important decisions which are reliable in this instance. So having electronics on a printed circuit board will allow you to consistently, reliably, and constantly measure anything that you want to measure in this day and age. There are sensors built to measure anything. So for example, if you want to measure temperature sensors, airflow, water flow, anything that you can think of under the sun, we can start this conversation by leaving down some comments in the chat below about some things that you want to measure within your company, within your applications that you think of in here, and we can discuss that as we go along. So obviously having the ability to measure anything under the sky gives you innovative and creative problem-solving capabilities. So sometimes if you're wondering, why is this process going one way, and to be able to understand that further, you need to be able to have data, and to be able to have data, you need to be able to measure accurately and reliably. And so this gives you innovative and creative headroom to solve your problems. And ultimately, electronics are also scalable, so they're infinitely scalable as well. So you can design something that's quite simple as a prototype and then develop that into a finished product, and they're infinitely scalable, and it's really effective to do something like this. And obviously, printed circuit boards are also pretty cost effective to be used as a data collection measurement tool. And this results in why we need prototypes. So when you're designing a design process, you want to be able to iterate, and you want to be able to have prototypes to actually show that what you're designing actually works in this instance. So today, this whole PCB InventX demonstration series is going to show you how we produce prototypes, printed circuit board prototypes in-house at the Aura Innovation Center here. So I'm going to use a case study that we have, a current knowledge transfer partnership project, a KTP project currently, University of Hull had, which is headed by Dr. Cheng Yong Chiang from the computer science department. He's working with a company called NCS, who are developing and employing telehealth devices around care and assisted living homes. And so obviously he's the project is designing sensors and stuff like that to actually be embedded within the overall package of the systems, which they are actually currently researching. So the title of the project is Designing All-in-One Vital Sign Point of Care System Analysis Tool. And this project is funded all the way through to 2023, funded by Innovate UK. And obviously one of the key points that they're very happy about the prototype facility that's available at the Aura Innovation Center is the ability to use high precision laser prototyping tool, which I will show you later on as part of the process. And they're happy with the results that they're getting and the ability to be able to produce something very accurately and reliable at the same time. So this is a super oversimplified 5-step prototyping journey that I'm going to take you on in this demonstration today. So I name it the PCB Prototyping Journey, and it starts all the way from design to structuring to drilling to plating and then finishing. So obviously we'll look at each step one by one within this process, and it all starts with how do we get this blank piece of copper plate to producing a single piece of depaneled PCB, and then all the way to finalizing, finishing, populating it with components, making sure it works the right way as it's designed, intended it to, and then also verifying that everything works okay before moving the design iteration all the way up, all through to its final design. So it'll be quite a quick whistle stop, few minutes for me to actually show you how it's all done in-house. So this green plate is a typical PCB that you will see, for example, underneath your laptops, your computers, and this is a finished prototype design board that we should be able to achieve in-house. So I'll take you on this process to go along with us. Let's go. Okay, so we start with the design process. So the design process starts immediately when you think of something that you want to measure. So for example, in this instance, let's take, say, if we want to measure airflow within a building, so to start with, you need to have a schematic design. You need to have an electronics design. And currently, it's really simple for anyone to start playing with electronics and learning how to design a circuit board. For example, you can use something like on the top corner here, top left picture here, something like an Arduino. An Arduino is really accessible. It's really affordable. Something like this is only 20 to 30 pounds, and you can actually put components onto it directly, write a few lines of code, and then it will be able to tell you and teach you along the way of how to design your own circuitry. So from there, you then design, and you then have the design schematic, and you need to get it to an engineer where they will then be able to design it onto a piece of board. So for example, using a CAD computer-aided design software, such as the ones that you see below in the video down there. So how you design the board in this prototyping process is actually quite crucial. So obviously when you're doing testing, you might end up like what you see on the image to the right here. But once it's designed, you have to go back a step, when you're designing this process, you need to decide if it's a single, double, or multi-layer board. So obviously the simplest designs will only go on a single layer board, and obviously the complexity goes up significantly with a double-sided or multi-layer board. And from there, you can then make design parameters and decisions based on what you need. But typically for us, prototyping, single side board is the fastest one to achieve, fastest one to produce, and it's the easiest one to handle. However, at this facility, we can handle up to 8 layers of multi-layer PCB design. So once we've had our full design, we then go into the structuring process. So PCB structuring is essentially a very cool word for saying where the copper is removed selectively and where you want it to. So remember the initial design that you've done, and once you put it all into the PCB machines, it will then be able to take it, remove the copper selectively. Currently in the house, we have 2 types of machines that can actually do that. One is via a laser, and another is via a mechanical mill. And so through this process, structuring also involves depaneling. So depaneling meaning, so for example, when you see a huge piece of A4 copper plate, and then if your circuit is only 1 inch by 1 inch tall and wide, depaneling is the machines be able to remove that single piece of PCB, like what you see in the example previously here. So here I've got a little video to show you the process that we go through to actually structure this. So here at the facility, we've got 2 laser machines we have in the PCB as part of the PCB suite. So this is one of the coolest machines that I think we have in-house on the PCB side of things, and it uses laser to actually remove the copper selectively on where we need it to be. So here you can see that there's an A4 piece of blank copper plate which is mounted onto the PCB laser machine, and it uses high pressure compressed air as well as vacuum at the same time to ensure that the PCB copper plate is actually adhered onto its base plate. So here the white piece of, it's not paper, it's actually a porous material to allow vacuum to be able to adhere onto the base copper plate, so the copper plate stays in place whilst the machine works on it. And in the middle, in the glass little cylinder, there are 2 lines. One is a compressed air line as well as a vacuum to ensure that all the copper that is removed cleanly and efficiently onto its refuse site. So here, one of our technicians are actually importing the design uploading onto the machine, and here he's mounting the copper board into the laser machine, and very quickly we're going to start structuring the PCB. So here is mounted a demo board onto there, and we're going to go straight into the board. You can actually see the laser working on the PCB, and on the top left corner of the image here, that's actually what the design that was uploaded onto the machine. So that's a depaneled piece of PCB. So you can actually see that the laser working through the design, removing, structuring areas of copper that isn't intended to be left on the board. So obviously all the circuit tracks, all the electronic circuit tracks will be left in place, and the laser takes it through several times depending on the settings and what depth it's needed to actually remove all that. And then this bit here is one of the coolest parts. It uses a different types of lens to actually shear off a layer by layer of the residual copper that's on the blank plate. So hopefully it shows it quite well on the video. So you can actually see that it literally is like a hoover scraping off, but via a laser. So this last step here is the depaneling. So it focuses the laser onto the edges of the blank plate of PCB, not blank anymore, and to be able to cut off that little single piece that you see. That is exactly like what is shown here. So post-structuring, this is actually what you see coming out from the PCB laser machine, and this is really, really cool. So obviously, yeah, now the video is actually repeating itself, but that's the PCB structuring, and hopefully you share the same feelings I have of knowing how cool this machine is. Unfortunately, obviously, it's really loud when it's working because of the vacuum, but the laser itself doesn't produce a single noise at all. Okay, so let's go on to step 3. So once the PCB structuring is done, the next step we go into is drilling. So drilling, remembering what you see on the finished panel. So some components, some PCB components you require drills to be drilled onto the PCB plate to be able to have components mounted onto it. Sometimes your PCB will have mounting holes and something like that, and that's really important to do that. So we can actually, again, do this drilling via laser or via a mechanical mill. Sometimes for larger holes, it's significantly more efficient to have this drilling performed with a mill. So we have one of this mill in-house, which will be mounted with different sizes of drill bits, and sometimes they're cutter bits or router bits, and it's all dependent on what is needed from the design. So the software, again, will automatically calculate what is needed in terms of tolerances and so on, and once you've uploaded the design all the way through to the computer, it will then guide you through this process of telling you which bits it needs. So for example, here you've got a router bit and it looks really, really sharp. So yeah, for example, one of the tool exchanges that's supposed to happen when the software is uploaded onto it, they'll tell you what bit is needed and when to put it on. So here we've got a technician putting that on to there, and the software will verify if this process is actually done correctly. So once that is done correctly, it will then move into its correct placement and position and starts drilling. So again, this process is really, really loud because there's a vacuum behind it to actually remove all the drilled dust from the PCB immediately onto its exhaust right behind the drill bit here, as you can see. So this one is a 1.5 mil hole, so it's actually quite big, and now it's telling us to change that into a 0.2 mil cutter. So again, it looks very, very different, and it looks pretty sharp. So once that's actually put on, again, the machine will then go on to its intended position and just continue drilling all the holes. So everything is produced accurately and reliably, dependent on the manufactured and design specification that we have. And a lot of it is intended and designed dependent on the application. So sometimes certain things you can have bigger tolerances, and some of the projects you need to have more tighter tolerances. And so this is what it looks like once it's all complete. So very, very nicely drilled demo that we have here. And this is the drilling machine that we use for the printed circuit board for step 3. Okay, so now that the drilling is done, let's move on to step 4. So step 4 is plating. So step 4 is the plating process out of step 5. And once we've completed the drilling, and the plating is only needed when you are doing a double-sided board. So double-sided board meaning you have a layer on the top and a layer on the bottom. So why is this needed? So for example, remember the drilling. So on this top image that you see here, so once you've drilled a hole onto the PCB, it is then the top and the bottom side isn't connected. And so to ensure that the track is connected, you need to ensure a layer of copper is deposited all the way from the top through the hole, through the cylinder, out on the bottom, and made sure that it's at a consistent layer of thickness. And to do that, you need to plate it. So the machines that we have in-house this time around to plate it is an electrochemical plating process. So obviously here we have a six-stage bath process that will take you all the way, from obviously cleaning the boards, prepping the boards, post-drilling to make sure that the conditions are optimal for the PCB to be actually plated consistently and reliably via the electro process. So here, obviously, we can see that we use different types of chemicals which are specified by the manufacturers. And then on here, you can see that Rob, the technician, cleaning and now plating the board. So whilst plating, you can actually see that there's a movement, back and forth movement within that, and make sure that all the solutions and chemicals are actually well agitated and consistent to ensure good results on this process. So the plating process takes about 2 hours, but obviously before we get to the plating process, there is also about 10 to 15 minutes depending on the cleaning process as well. So yeah, so just to repeat myself again, so the plating process is only required if you only need to do a double design, a double layer top and bottom and multi-layered boards. So if you only have single layer top or bottom, there's no need for plating. Okay. And finally, we talk about finishing. So finishing in terms of PCB prototyping means a lot. So it actually means that once you've completed all your first 4 steps, the last bits that you need to look at are now essentially making sure that the components are populated correctly, but also before that, you need to make sure that the tracks and the circuit that you've actually produced is actually fitting the design requirements. So copper places where copper shouldn't be there needs to be taken off. It needs to be ensured that it's taken off correctly, and tracks needs to be in good condition to make sure that the quality of the circuitry is actually there, and the integrity to make sure that it's all there. And then also we need to make sure that the components are populated according to what it's designed to. So obviously there are 3 types of PCB electronic components that you have. So you have the through-hole types of component, which is the ones where you drill holes and they stick onto it. And then you have the surface-mounted devices, which just sits on top of the PCB. And obviously the 3rd type is the ball grid arrays. But unfortunately, we don't do the ball grid arrays in-house, the PCBs that we produce. But we can do work on it. And I'll show you that later on. So for example, here you can see in the video, Rob taking out the PCB from the laser machine, and because we're doing only a top single side board, we don't do any plating. So this goes to his inspection, and here you can actually see that some of the tracks which are produced by the laser is actually in good condition. They're actually consistently, the widths are consistent, and the etching process, the structuring process of the copper looks pretty good. And then one of the next thing he does is making sure that the areas that needs to be conductive stays conductive, and the areas that doesn't need to be conductive shouldn't be. So this is one of his testing steps as well. And then so here we have one of our pick and place machines to ensure that the surface mounted devices components are placed onto the PCB. Obviously these are the components are bought in based on project. So this machine currently is empty because we're not using it for this demo. So yeah, so this is one of the proto-place machines, the pick and place machine. So it uses minimal suction to pick up a piece of component and then puts it onto its corresponding position on the circuit board. And here we have a press to allow us to actually produce our 8-layer PCB machines. So 4 layers of double-sided machines get compressed into one with the hydraulic press to make our 8th layer. Early on, you also saw that we have a reflow oven to ensure that all the solder paste that we do from surface mounted devices are actually consistently, I call it baked, but then, yeah, so it essentially is baking it, making sure that all the solder flow is actually flowed properly here. So one of the last machines that we have here is the BGA ball grid array rework machine. Let me quickly skip on to that section again. Yeah. So this is the ball grid array machine, rework machine that we have in the house as well. So if we needed to actually work on ball grid arrays, removing some of the damaged components, we can do that in the house as well. So this is part of our prototyping facility that we have on here. So I hope there's been some questions. So we've gone through a very quick 5-step process. Let's see. Yep. So that is an extremely simplified and quick demo for us to actually show you how we prototype our printed circuit boards in-house at the AIC. And it's important to revisit why printed circuit boards are actually important for your business and how they can support your business to generate more revenue down the line. So, really to think about how, what advantages it will bring onto your business and how it can actually help you measure, record, and control a lot of new processes that you want to implement onto your products or applications or services and have them done consistently, reliably, and constantly to your control as well. And obviously, having printed circuit boards and electronics also allow you to have innovative and creative problem-solving ability within your products and also services and applications. And it is also very scalable, easily scalable, and at the same time, very cost-effective. And obviously, we're always happy to produce prototypes in-house for you. So the most important thing is to get in touch with us. So obviously, get in touch with us at the Aura Innovation Center at aura-innovation.co.uk. That's the website that you go to. Also, come see us at the floodinnovation.co.uk. So we have a lot of information on the website. So please do get in touch. So the key thing is, if you have any ideas that pops into your head, get in touch with us, and we'll be able to discuss that with you a lot more. So this is the Q&A section right now. So hopefully we've got some questions coming in. Do we have any questions? So let me launch the Q&A box. Okay. Oops. At the same time, can I introduce Dr. Alice Marshall from AIC to come in to answer any questions that we might have. And also we might be able to bounce some ideas and questions around. Welcome.
Brilliant. So thank you, Chun, for having me. Very interesting talk. It was great. So I've got a few questions actually. The Flood Innovation Centre is all around flooding and sensors. How can businesses interact with you? What innovative technologies could they utilize with you?
Let me unmute myself. Oh, there we go. Yes. So a lot of the businesses that we work with are actually not operating within the traditional flood sector. So I think a lot of people think about flooding and you think about sandbags and things like that. But however, there's a huge wide range of businesses that we work with. So for example, not just like landscape architects and so on. So we even have the, well, I'm not sure if I can actually name any names, but we have fire rescue departments working with us to actually develop systems and services as well. We also have risk assessment companies to actually try and learn more about the sector where they can produce their products which are actually catered towards the flood resilience sector. Property flood resilience is also another sector that is actually hugely growing. We've also conducted, besides the property flood resilience sector, we're also working with a lot of landowners and a lot of farmers as well, working on natural flood management techniques, working with stakeholders and end users at the same time. So so we cover a huge wide range of businesses and sectors, which not just the traditional flood sector operate in as well. So any ideas that you can have, come to us and we'll be able to bounce it around our team and give you some really good advice on how to proceed with this.
Brilliant. Thank you very much. So I've got another question that's come in. Do we have a list of equipment that is available? So in the next couple of months, there will be some updates on that, and that will come live, and you'll see it on LinkedIn, Twitter, everywhere. We'll be shouting about it when it comes out. So another question as well. Someone missed how they can get in touch. So Chun, how can they get in touch?
Yep. So the easiest way to get in touch with us would be to go onto the website. The Float Innovation Center would be at floatinnovation.co.uk, and for Aura Innovation Center, it's aura-innovation.co.uk. There are plenty of information out there on these websites, but crucially, there's a contact page for you to get in touch with us. And as soon as you get in touch, one of our members of the team will get in touch with you. And so, for example, don't worry if you have to go to the Float Innovation Center or the Aura Innovation Center, because we work very closely together. And if the business is actually better suited to Aura Innovation Center, your project, we will then pass you on to the Aura Innovation Center, as well as the other 3 industry-facing innovation support groups that we have within the university as well. So do get in touch with us.
Brilliant. So yeah, just one question as well. You can answer this, Chun. Is there any funding available to be able to utilize these facilities?
Yes, so that's actually a really good question. So for example, with the Float Innovation Center, so if you come on board with us, and so obviously the Float Innovation Center, it has a fully funded innovation support package. So for example, if you were to work with us and you qualify for the support that we provide, there's no cost to the company to be able to use these equipment. I think the only cost is their time. But then, there's no financial cost associated to working with us. That's a really good question. I think just to add on top of that, Alice, can you tell the viewers about the other InventX live demo that you have of the facility at the AIC here?
Yep. So yeah, the current video is just a quick glimpse of one of our webinars that we did. So this was on advanced materials. This year we've been hosting the InventX demonstration series, where we've gone through 3D printing, CAD modeling, and advanced materials. And today you're seeing our printed circuit board. And in the future, we're having our digital webinar as well. So it's all very exciting, and we do hope you tune in for the digital webinar coming up. And also, please do go on YouTube and see the links to our Festival of Green Innovation, to our whole webinar series that's available. And also the Float Innovation Centre also have a lot of videos available on the YouTube link as well. So please do check them out. And I think with that, I'll leave Chun to wrap up. So thank you.
Well, I didn't realize we're on time. We're up for time. No, so hopefully today, thank you to everyone who's watching. Hopefully we've given you a very quick whistle-stop tour of the prototyping ability available at the Aura Innovation Center, and hopefully, stimulated you and your companies to have some new ideas on how to utilize electronics and, down the line, needing prototypes, printed circuit boards done. And so we're looking forward to hear from you to come and work with us on your amazing ideas. So so hopefully hear from you all, and we will see you next time.